All right, quadratic formula. The formula. We're going to plug stuff into it and simplify it. Try to do our best with that. Quadratic formula is more similar to factoring than the others than solving by square roots or completing the square, because we've got to get the equation equal to 0 first. That's the rule for factoring. That's the rule for quadratic formula, that you've got to get the equation equal to 0 first. And it needs to be in this form: ax squared plus bx plus c. So that's descending order, the typical, quadratic equation there. All right. Quadratic formula is this. I don't know why I picked red, but I'm going to change it. X equals negative b plus or minus the square root b squared minus 4ac divided by 2a. You need to have that memorized if you don't already. Okay, so negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right. If you had me in Algebra 1, we sang this to the tune of row, row, row your boat. So if you're not good at memorizing things, you can put it to that tune. It goes x equals negative b plus or minus radical b squared minus 4ac divided by 2a. And so you can memorize it that way if you want to. I don't care how you memorize it. Just remember it, because they're not going to give it to you on the ACT. And it's questionable where they'll give it to you on the EOC or not. They're revamping the reference sheet for EOC, and they haven't really told us what they're going to put on it. And I think quadratic formula was on it. No, actually, it wasn't on it last year. They haven't told us what they're going to do there. Now, inside of the quadratic formula, there's this thing called the discriminant. And what it does is discriminates what kind of answers you have. That discriminant is the b squared minus 4ac part. It's the part inside of the square root. If that is a number that's less than 0, what kind of number is it? What kind of numbers are less than 0? Negative. If a negative is in the square root, what's that do to the problem? To the answers? An I comes out, right? That's where that comes from. What that implies is that there are two complex solutions. When the discriminant b squared minus 4ac is negative or less than 0, there are two complex solutions to the problem. If b squared minus 4ac is equal to 0, well, it's no longer complex, right? It's one real solution. Because what's the square root of 0? 0, always, right? And then in the formula, you'd be saying negative b plus or minus 0. And if you add 0 to something, what does it do? Nothing, right? Doesn't change it. If you subtract 0 from something, it doesn't change it. So you end up with just one answer there. Negative b divided by 2a is the only answer when the discriminant is equal to 0. And then one last scenario is when the discriminant b squared minus 4ac is greater than 0. That implies that there are two real solutions. Two real solutions. So, quadratic formula, coming from a quadratic equation that's equal to 0, negative b plus or minus square root of b squared minus 4ac divided, all of that is divided by 2a. Not just one part of it, the whole top part is divided by 2a. And then we can determine what kind of solutions we would have based on what's underneath the square root. The discriminant is what that's called. Okay, so need to be able to do those sort of things. with this. So let's look at some examples, and we're going to go through all of that stuff with this. Solve quadratic formula. All right, so let's say we had x squared plus 3x equals 2. Well, if we're going to solve this by quadratic formula, what does the equation have to be equal to? 0. It's not equal to 0. Make it equal to 0. Subtract 2. Gets it over there. There's 0. We got x squared plus 3x minus 2 is equal to 0. Now, in my Algebra 1 classes, I make me a list of A, B, and C. And that may help you if you struggle with this a little bit, or maybe didn't do well with it in Algebra 1. But making that list, what's A in this problem? 1. It's the number that's in front of x squared. What's B? 3. That's the number in front of x. And then C, negative 2. It's the constant on the end. Okay. And again, remember, it's got to be equal to 0 before we can do that. So if we've got A, B, and C, then we can take that and find the discriminant. Remember the formula, b squared minus 4ac. Let's find that discriminant. So in our case, it'd be 3 squared minus 4 times 1 times negative 2. And you're just going to work that out. 3 squared is 9. Negative 4 times positive 1. Negative 4 times negative 2 be positive 8. So the discriminant is 17. That's what kind of number? Is it less than 0, equal to 0, or greater than 0? Greater than 0. It's a positive number. So that means that we have what kind of answers? 2 real solutions. 2 real solutions based on that. Now, when we start relating this to graphing next week, what that tells us also is this thing crosses the x-axis twice. That's what that tells us when we start relating this to graphing. So that discriminant really has a lot of power here, or it tells us a lot of detail about our problem. All right, so the next thing to do is just work out the problem. The great thing about doing the discriminant first is that you don't have to have such a jumbled up formula going on there. We already know what b squared minus 4ac is. So when I go to set up my quadratic formula, I'm going to do negative b, that'd be negative 3, plus or minus radical, excuse me, and then b squared minus 4ac. I already worked that part out. It's 17, so I'm just going to put 17 there. Over 2 times a. And then I try to simplify anything that can. We would look at the square root and say, can I simplify the square root of 17? Can I? 17 is prime, right? So it doesn't break down. Nothing comes out of the radical there, so it's not going to simplify there. 2 times 1 is 2. So on the bottom, we just got 2. So we got negative 3 plus or minus the square root of 17, all divided by 2. That's 2 answers. One of them is x equals negative 3 plus the square root of 17. Divide that by 2. One is negative 3 minus the square root of 17. Divide that by 2. Today, in this section, I want us to get that exact solution, and we're going to go ahead and get a decimal approximation for that as well. So we need to work out what negative 3 plus the square root of 17 is, and then divide that by 2. So negative 3 plus the square root of 17, 1.123 divided by 2. And I'm going to round the 2 decimal places to the nearest hundredths place. So look at the 1. Does it make the 6 stay the same or go up? Stay the same. What does it have to be if it makes it go up? a 5 or bigger. Yeah, remember your rounding rules there. So the decimal approximation for that would be 0.56. There's one answer. Let's get the other one. It would be -3 minus the square root of 17. And then we're dividing that by 2. And that would be -3.56. The exact solution and a decimal approximation for that. I'm looking for both of those. One without the other. If I'm going to have one without the other, I'd rather have the exact solution, honestly. Okay. All right. Let's do another. X squared equals 6x minus 4. What's wrong with this one? Okay, it's not equal to what? 0. Not necessarily that x squared is not on the wrong side, but it's more that it's not equal to 0. That's the problem. So one option to get that equal to 0 would be to do what? Yeah, we can move 6x minus 4 to the other side. That would leave what positive? The x squared, which is, if we're going to factor, definitely what we would do. If we were going to try to factor that, that would be the approach that I would take. But since we're doing quadratic formula, we could be a little bit faster by one step by just moving x squared, and it would give us a negative in there, but it still gets it equal to 0. So what Katie said was move 6x and 4, and that's not wrong at all. It's still going to get the same answers as moving x squared. What could we do to get the exact same answer Katie would have got? Divide by -1. That's legal because if you divide 0 by -1, what happens? Still 0, right? So you technically could do that if you wanted to. I'm going to work it with the negative in there just so that we can see that it works the same way. So A in this case would be -1, B for me was +6, and C is -4. I'm still going to do the discriminant. That'd be 6 squared minus 4 times -1 times -4. Working that out. Be 36 minus 16. Just +20. So that means there's how many solutions and what kind? 2 reals. So that means when we talk about graphing next week, that means it's going to cross the x-axis twice. That's what that means. Okay? X equals -b plus or minus radical b squared minus 4ac divided by 2a. And we just got to work that out. Will the square root of 20 simplify? Yeah, because 20 breaks down to 5 and 4, and there's a pair of 2's. So we have x equals -6 plus or minus 2 radical 5 over -2. What do we know about all of those numbers that are highlighted there? They're all even, which means they're all divisible by 2. Divide them by 2, not just 2, but we got a negative on the bottom. We usually don't want to leave the negative hanging here and a negative hanging there. All right. So I'm going to divide everybody by -2. So if I divide -6 by -2, that's going to give me +3. +2 divided by -2, -1. -2 divided by -2, +1. So I still have a plus or minus, and then the square root of 5. What's in the denominator now? technically 1, but do we have to write that? No, anytime it's over 1, we don't have to write that. So we have 3 plus or minus the square root of 5. The same answer we would have gotten if we'd done it the way Katie said and moved 6 and 4. It gets the exact same answer. You can't screw it up as long as you put the right numbers in there. That's the great thing about quadratic formula. That as long as you get it equal to 0 and you don't make a mistake on signs and you plug everything in correctly, it'll get you the right answer. Now, if you miss a sign, yeah, that's where it's going to happen. That's usually the mistake. So we have 2 answers, 3 plus the square root of 5, 3 minus the square root of 5. And let's get the decimal approximation for each of those. 3 plus the square root of 5. Rounding to 2 decimal places, so hundredths, be 5 point what? 24. Because we look at the 6 that's after the 3, it's 5 or bigger, so that makes that 24. 5.24. And then 3 minus the square root of 5. It'd be 0.7 what? Rounding to 2 decimal places, guys, not 3. 0.76, wouldn't it? Just 0.76. And there we have our 2 answers. The exact solution and then the decimal approximation for that. Not bad. Look at this one. Negative x squared plus 4x equals 5. What's wrong with this one? Not equal to 0 again. What are our options for getting that equal to 0? Move the 5, or we could do what? Move these other 2 pieces. It doesn't matter which one you do. It's going to get you the same answer. So I always just take the shortest route. Negative x squared plus 4x minus 5 equals 0. And if you don't like all those negatives in there, just divide everybody by -1. It changes their signs. Okay? If you don't like the negatives. Okay. Discriminant. 4 squared minus 4 times -1 times -5. That 4 right here, this 4 in the middle there is always there. It's always there. Simplify that, so that's 16. Positive 4 and -5 be -20. That's -4. What does a negative discriminant tell us? Too complex. Solutions. Now go ahead and relating that to graphs next week. That means this thing won't touch or cross the x-axis. That's what's that negative discriminant tells us. All right, so it's 2 complex solutions. So we know there's going to be an I in our answer. That's what we know by knowing the discriminant's a negative number. So x equals -b plus or minus radical b squared minus 4ac divided by 2a. Work it out. -4 plus or minus. What's the square root of -4? 2i. What do we know about all of the numbers now? They're all divisible by what? 2. And since that's a -2 in the bottom, I'm going to divide by -2. So that becomes +4 plus or minus, not +4, +2 plus or minus I. 4 divided by 2 is 2. Last time I checked, I forgot. Now, can we get a decimal approximation for that? No. Those are our answers. If it's complex, it's easier because you don't have to get the decimal approximations. One less step that you've got to do. but it's still the quadratic formula. Doing the discriminant first, and then plugging in the other stuff and going from there. Let's look at another one here. Let's say we had 7x minus 5x squared minus 4 equals 2x plus 3. This one is a jumbled mess. Not even, Susan. You're not.
It's called life, isn't it?
Yeah. Yes, ma'am. Absolutely. All right. So we got to work it out. So what do we need to do? What are we trying to get? 0 on one side. Doesn't matter which side. If I'm looking for path of least resistance, I'm saying, okay, well, the side that's got 2 pieces on it would be shorter to move than the side that's got 3 pieces, right? So how do I move that? All right, subtract 2x from 7x, and then subtract 3 from negative 4, right? And then put it in the right order when you rewrite it. So negative 5x squared should come first, plus 5x, then a minus 7. And I've worked with a lot of negatives here the last couple examples. I don't want to work with as many this time. So what can I do to get rid of them? Divide everybody by negative 1, even the zeros. Just to change those signs, because I'm tired of working with negatives. Okay? What's the Facebook mean? You don't need that kind of negativity in your life. All right. Now, got A, B, and C. We can find the discriminant based on those. What is the discriminant? What's the formula for it? Technically, it's negative 5, yes. 4 times 5 times 7. So it'd be 25 minus what? 4 times 5 is 20. 20 times 7 would be 140. So the discriminant is a negative number. What negative number? Negative 115. Again, that tells us we have what kind of solutions? 2 complex. All right, 2 complex solutions. Let's find those complex solutions. X equals negative b plus or minus radical b squared minus 1 or AC divided by 2a, and a is 5. All right, so we got to think about breaking down the 115. I know 5 goes into it 23 times, but then it doesn't go any further. So 115 nothing comes out except for what? The I. This is x equals 5 plus or minus I radical 115 over 10. Technically, that's a correct solution. We're going to go one step further because what do we know about the 5 and the 10? They could reduce, right? So if we split that apart into 5 over 10 plus or minus I radical 115 over 10, we can reduce this guy. Okay, so that makes the problem in complex number form, remember it had the real part and the imaginary part, so that'd be 1/2 plus or minus square root of 115 I square root of 115 over 10. All right. And nothing we can't get a decimal approximation for it because the I in there. So we got that. Just leave it that way. All right. Let's do one more. That other case for the discriminant, we haven't done one like that yet. So let's get one knocked out like that. (4x squared minus 10x equals 2x minus 9. What do I do first? Get 0 on one side. I'm going to move this other stuff. And then plus 9 somewhere there. There's my 0. 4x squared minus 12x plus 9. Remember, descending order, ax squared plus bx plus c is the format you need. And then let's find the discriminant. So it'd be negative 12 squared minus 4 times a times c. Okay. That's 144 minus 4 times 4 is 16. 16 times 9, 90, and 54, which is 144 again. That's the discriminant. 0. What's that tell us about solution? Wrong. 1 real solution. So when we go to our quadratic formula, it's x equals negative b plus or minus radical b squared minus 4ac is 0 in this case. So that's the easiest square root to take. Maybe 1 is just as easy, but square root of 0 is 0, right? And on the bottom, we got 2 times a. So what's the square root of 0? It's 0, right? So we have 12 plus or minus 0. So really all that's up there is what? 12. So this simplifies to be 12 over 8. That's a fraction. Anytime we get a fraction, we need to look and see if we can do what to it? Simplify, reduce it. 12 and 8 are both divisible by 4. 3 over 2. And that's technically 1.5, but it's not. We're not approximating that. That's exactly what that is. Okay, so there's a case where the discriminant is 0. Those shorten up pretty quick when that happens. It makes for a nice, easy answer. All right. So some practice with this for the, you got about 10 minutes left in class today. Page 296, 3 through 29, and then 41 through 47. Let's just do the odd ones. I think you guys have seen this before. It's not gonna, only thing that's changing, I don't think that we didn't do in Algebra 1 is the complex numbers involved. We didn't have that involved in Algebra 1, but in Algebra, you guys pick that up very quickly and easily. So practice tomorrow. My yearbook folks, if you are comfortable toward the end of class tomorrow, if you want to take your quiz tomorrow so that you don't have to wait till Monday to do that, that's fine. Skinny block would be fine tomorrow if we don't have time at the end of class or whatever. What block is your book? 4th? Lunch block? Okay. I would say come in during that time, but I have 32 kids in here at that time. I don't have an empty seat, so I wouldn't have anywhere to put you.